So quantum mechanics, okay, these are rules that help to explain how electrons behave. If you understand how electrons behave, our most modern understanding of it, then it helps you predict everything you ever need to know about any element, any compound, anywhere. Okay? This has only been around for maybe the last 100, 150 years, probably closer to the last 100, bless you. And principally, when we talk quantum mechanics, we talk about electron behavior, we talk about 4 different scientists that came up with 4 different rules. Okay? First one, of course, is Heisenberg, Big Papa. Heisenberg basically says that it's impossible to know both the location of and velocity of and direction of an electron. You can maybe know, for instance, where an electron is. You can maybe know, for instance, where an electron is going or its velocity, but you can't know both. Okay? So Heisenberg says you can't know exact position, etc. of an electron. So when we talk about quantum mechanics, what we're talking about is probability. Okay? When I say an electron is at, like, 1s1 or 1s2 or whatever, I don't know that for sure. I know that that's where it's most likely going to be because that's where an electron tends to be the most stable, where it has the lowest potential energy, okay? Where it's the most comfortable. But it could be anywhere, literally, like anywhere in the universe. Now, following that up, 3 of the rules we talked about the Aufbau principle. Aufbau is the one that said electrons are going to be at the lowest possible energy. Okay? Because that's where they are the most stable. Okay? When I was teaching you this first time, I said that the Aufbau principle was kind of like a glass of water. When I put water into a cup, where does the water go? It goes to the bottom. Why does it go to the bottom? Because it would be weird if it just floated up the top, right? Same thing for electrons. Electrons, if you think about all the sublevels and energy levels and stuff in an atom, like a glass of water, electrons are going to want to get as close to the nucleus as possible because that's where they're the most stable. That's where they have the least energy. Okay? They're going to fill up energy level 1 before they start filling up energy level 2 and energy level 3 and so on. They're going to fill up the S's before they fill up the next level of S's and P's, or the next level of S's and P's and D's and F's and so on. Okay? Aufbau starts with letter A. You got to go to A before you go to B and C and D. Okay? Lowest possible energy levels. We also have the Pauli exclusion principle. Pauli said that it's possible for electrons, they're not positive, it's possible for 2 electrons can share an orbital. They can be roommates if they have opposite spin. If one of them has a spin of +1/2 and the other one has a spin of -1/2. They can't have the same spin and share the same space because then they crash into each other. Okay? It's the Pauli exclusion principle because each address where you could find an electron is exclusive. Okay? Meaning only one electron can be there at any one time. And then the last one, I think, is Hund's rule. Hund's rule basically says that if you've got multiple orbitals that have the same energy, when I start dropping electrons into here, what they're going to do is they are going to sort out one per orbital before they go back and add a second. That would be like 1, 2, 3, 4, and so on. Okay? Because while they're all trying to get as close to the nucleus as possible, because that positive nucleus is drawing them in, they're also all little negative charges and they push away from each other, so they repel each other at the same time. They're all trying to get to the same place. So those are the rules that electrons tend to follow, and that's our, in a nutshell, our understanding of electron behavior. That's quantum mechanics. Okay, any questions? All right.